Now we're looking at a special set of triangles that fit the Pythagorean theorem. These are called the Pythagorean triples, and they're a real time saver if you can learn 2 to 3 of the basic triples. So, what is a triple? Well, they're special right triangles where the sides are non-zero whole numbers. So they're the numbers you like, the integers. Common triples include the 3, 4, 5, the 5, 12, 13, the 8, 15, and 17, and the 7, 24, 25. In fact, one of our examples was the 7, 24, 25. Some of you already know about the 3, 4, 5. This is one of the most common. And honestly, the other one that we really use is the 5, 12, 13. So if you know no other triples, know the 3, 4, 5 and the 5, 12, 13. Now, if you recognize that a right triangle is related to a triple, you can apply a scale factor or multiplier to find the missing side. So we're going to use some multipliers to create some other triples from the 5, 12, 13 triangle. There are my 3 sides. Let's go ahead and double them. So the 5, 12, 13 triangle is related, it's similar to the 10, 24, 26 triangle. For the 10, 24, 26 triangle, every side is twice as big as the 5, 12, 13 triangle. Now I'm going to apply a factor of 3. So I'm going to create another triple from the 5, 12, 13 using the scale factor of 3. So that gives me the 15, 36, 39 triangle. And if you look at it, you can see that all of these are divisible by 3, and you can get back to the 5, 12, 13. Finally, I'm going to do a multiplier of 4, so I get a 20, 48, 52 triangle. Now, one thing you might do is you might be asked, okay, what's the original triple? So we're going to kind of use the same thing. So we're going to make a ratio of the known sides. Now, the way I have it in here, the x is in the right spot. So this is the larger side, and this one's the smaller side. I create a ratio from 9 to 12, and I simplify it, dividing by 3 over 3. 9 divided by 3 is 3. 12 divided by 3 is 4. So this is like a 3, 4 blank. Well, that's our favorite, the 3, 4, 5 triangle. And we got it because these sides are 3 times bigger, so my scale factor is 3. Which means my missing side is going to be 3 times 5, or 15. I'm going to do the same thing for this next triangle. Create a ratio of 72 to 75. And again, in this case, it's 3 that I can simplify both by. And I get 24, 25. Now, this side's supposed to be smaller, so you might recognize this as the 7, 24, 25 triangle. Since the scale factor is 3, my missing side is 3 times 7, or 21. So for further reflection, what is a Pythagorean triple, and how can you create more of them? How can you recognize the original triple used to create the triangle?